This is a short tutorial on how to model a Thirsty Duck TDP series floating outlet and skimmer in HydroCAD. This tutorial also includes a procedure for optimizing the volume of detention storage. HydroCAD software allows for 3 different ways to model Thirsty Duck floating outlets and skimmers. The 3 available outlet options are 1. Constant flow skimmer, 2. Special and user-defined outlet using the built-in Normalized Thirsty Duck rating curve, and 3. Special and user-defined outlet using an imported rating curve created in the Thirsty Duck TDP series design tool. For final designs, Thirsty Duck recommends using the special user-defined outlet with an imported rating curve created with the TDP series design tool. The design tool may be accessed from the Thirsty Duck website at www.thirsty-duck.com. In this tutorial, we will analyse an underground stormwater detention system designed for the following hydrologic characteristics. The subcatchment area is 1.75 acres of commercial development, comprised of 1.4 acres of impervious surface. CN equals 98. And 0.35 acres of pervious surface, CN equals 74. The time of concentration is 15 minutes, and the design storm events have 2-year, 10-year and 100-year return frequencies. The rainfall distribution is SCS Type 2, with the following 24-hour rainfall depths. 2-year, 3.28 inches. 10-year, 4.83 inches, 100-year, 7.63 inches. The allowable peak discharge rates are 2-year, 1.55 CFS, 10-year, 3.33 CFS, 100-year, 6.97 CFS. For the purposes of comparison, we will start with a traditional system design which meets the project requirements. The storage consists of 1,200 linear feet of 48-inch diameter corrugated metal pipe, having an invert elevation of 100.00 and no slope. No freeboard is required, and the outfall has sufficient conveyance such that the HGL will always be below Thirsty Duck's flow restrictor module. The outlet riser is a 12-inch diameter CMP with 2 6-inch diameter orifices having invert elevations of 100.00 and 102.00. The top of the riser is at elevation 103.00. All elevations are referred to NAVD88. HydroCAD indicates the following peak stages and flow rates. 2-year flow rate, 1.13 CFS with a peak stage elevation of 101.68. 10-year flow rate, 1.86 CFS with a peak stage elevation of 102.48. 100-year flow rate, 6.11 CFS with a peak stage elevation of 103.72. When designing a stormwater detention system for multiple return frequency events, Thirsty Duck is most often sized to produce the allowable peak flow rate for the most frequently recurring event. For this example, the most frequent event is the 2-year storm, which has an allowable discharge rate of 1.55 CFS. Traditional orifices or weirs are designed for the control of the less frequent storm events, the 10-year and 100-year, for this example. Using the orifice diameter selection chart located in the TDP series design tool, find the orifice diameter corresponding to 1.55 CFS. Note: green bars are Thirsty Duck model TDP 184, while blue bars are Thirsty Duck model TDP 248. For this example, the chart indicates model TDP 248 should be used with either a 7.5-inch diameter orifice or an 8-inch diameter orifice. We will choose the 8-inch diameter orifice since it requires less operating head to achieve the design flow rate. Open the data entry worksheet in the TDP series design tool and enter the project name, datum, model number and nominal orifice diameter chosen from the orifice diameter selection chart. Next, input the system design elevations. For this example, the maximum storage elevation is 104.00 and the minimum discharge elevation is 100.00. Since no freeboard is required in this example, the design peak stage is 104.00, and any value less than 100.00 may be used for the design tailwater, since free discharge conditions are anticipated. Use the Goal Seek function in Excel to determine the design operating head required to produce 1.55 CFS. For this example, Goal Seek returns a value of 8.64 inches. Since Thirsty Duck recommends rounding operating head to the nearest quarter inch, round the value down to 8.50 inches. Rounding up to 8.75 inches produces a flow rate higher than 1.55 CFS. For this example, Thirsty Duck will control all water surface elevations. Select Case A for the installation case. If you are not familiar with Case A and B installations, please see our short tutorial on the hydraulic principles behind the Thirsty Duck TDP series floating outlet and skimmer. Last, enter the rating curve computation increment. For this example, we will use the default of 0.05 feet. Open the Export worksheet in the TDP series design tool and select the values in the stage and discharge columns between elevations 100.00 and 104. Right-click and copy the data to the clipboard. Since HydroCAD requires rating curves be imported in CSV format, open a new blank Excel workbook and paste the data from the clipboard into a worksheet at cell A2. HydroCAD assumes the first row of any CSV file is a header row and will ignore any values in that row. Save the workbook as a CSV type file. For this example, we will name the file ratingcurve.csv. Close the CSV file. Note, HydroCAD will not read a CSV file which is open. Open HydroCAD and edit the pond created for the comparison example. Select the Outlets tab and delete the orifice at elevation 100.00. The Thirsty Duck rating curve will replace this orifice. Add a new special and user-defined outlet. Select Load from File and browse for the CSV file created in the previous step. When you have located the CSV file, HydroCAD will immediately load the first 50 rows of data and ask if you wish to continue loading. Select OK. Since the Thirsty Duck rating curve is a stage versus discharge relationship, leave the invert elevation at the default value of 0.00. Note, HydroCAD assumes rating curves are head, not elevation, versus discharge relationships if the value of the invert elevation is not 0.00. Execute the routing for the 2-year event, and HydroCAD will display the inflow and outflow hydrographs. For this example, HydroCAD indicates the peak discharge rate is 1.49 CFS, and the peak water surface elevation is 101.33. Since the peak discharge for 2-year storm is slightly lower than the allowable discharge rate of 1.55 CFS, it may prove valuable to adjust the Thirsty Duck rating curve to produce a slightly larger discharge rate. Reopen the TDP series design tool and increase the operating head. Increase the flow rate by the difference between the allowable discharge rate and the peak discharge rate determined in the routing. For this example, the difference is 0.06 CFS. A design operating head of 9.25 inches will increase the discharge rate by approximately 0.06 CFS. Save the updated version of the rating curve to a CSV file as shown earlier in this tutorial. Reopen the Special and User-Defined outlet in HydroCAD and load the updated rating curve from the CSV file. Re-execute the routing for the 2-year event. HydroCAD indicates the peak water surface elevation is 101.31 and the peak discharge rate is equal to the allowable discharge rate of 1.55 CFS. Now, design traditional orifices and/or weirs to control the discharge rates from the 10-year and 100-year events. After several iterations, it was determined 2 8-inch diameter vertical orifices with invert elevations of 101.30 and 1 8-inch diameter vertical orifice having an invert elevation of 101.90 meet the peak discharge criteria. For the 100-year event, HydroCAD indicates the peak water surface elevation is 102.79 and the total volume stored is 0.258 acre-feet. Since the peak water surface elevation for the 100-year event is lower than the allowable peak stage of 104.00, the length of pipe storage may be reduced. Reduce the length of storage until a volume of 0.258 acre-feet is achieved at or near elevation 104.00. Reducing the length of pipe storage by 25% to 900 linear feet provides 0.258 acre-feet of storage at elevation 104.00. After several more iterations at the reduced storage volume, it was determined the following riser configuration meets the peak discharge and peak water surface elevation criteria. 1 10-inch diameter vertically oriented orifice with an invert elevation of 101.60 and 1 8-inch diameter vertically oriented orifice with an invert elevation of 102.40. Of course, this configuration is only one of many possible valid solutions. Thirsty Duck encourages you to try a variety of outlet configurations when optimizing the volume of detention storage. Now, let's reanalyze the design using the constant flow skimmer outlet option. For this option, HydroCAD approximates the Thirsty Duck rating curve with a 3-point curve. The 3-point curve assumes perfectly constant outflow and a linear transition to full flow. Delete the Thirsty Duck rating curve imported from the CSV file and create a constant flow skimmer outlet. Set the invert elevation to 100.00 and the phase-in depth to 0.77 feet, 9.25 inches. The phase-in depth is the Thirsty Duck operating head. Then set the full flow to 1.55 CFS and click OK. Re-execute the routing. HydroCAD indicates the peak discharge rate for the 2-year event is 1.56 CFS, which is slightly in excess of the allowable discharge rate of 1.55 CFS. After an additional iteration, it was determined that adjusting the invert elevation of the 10-inch diameter orifice to 101.65 produces peak discharge rates for the 2, 10 and 100-year events, which meet the design criteria while keeping the peak water surface elevation for the 100-year event below elevation 104.00. Thirsty Duck encourages you to try a variety of outlet configurations when optimizing the volume of detention storage. Now, let's reanalyze the design using the special and user-defined outlet with the built-in Normalized Thirsty Duck rating curve option. Delete the constant flow skimmer outlet used in the previous example and create a new special user-defined outlet. Select Load from File and then double-click on the Thirsty Duck folder and select the file for the appropriate model number. For this example, select Thirsty Duck TDP248.csv. Input the invert elevation of 100.00 feet and set the discharge multiplier to 1.55. The normalized rating curve in HydroCAD produces the design flow rate when water surface elevation is 5 feet above the invert elevation. This is unlike the constant flow skimmer option, which produces the design flow rate at the phase-in depth. Therefore, this option should produce peak discharge rates, which are slightly lower than those produced when using the constant flow skimmer option. Re-executing the routing yields peak flow rates and water surface elevations which meet the design criteria but are slightly different than those predicted using the constant flow skimmer option. The chart on the screen is a plot of the Thirsty Duck rating curve used for each of the analyses in this tutorial. Note the rating curves for the constant flow skimmer option and the normalized rating curve option are close approximations of the rating curve generated by the TDP series design tool. Thirsty Duck always recommends using a rating curve imported from the design tool for final designs. However, the constant flow skimmer and normalized rating curve options are very useful for quickly producing preliminary designs. Thank you for watching this short tutorial on how to model the Thirsty Duck TDP series in HydroCAD. If you have any questions or comments regarding this tutorial, please feel free to contact us through our website at www.thirsty-duck.com. We are always happy to review or assist with modelling at no charge.